Hello, this is Sean McGowan doing my video submission for Lab 4 of ENME 351. In this lab, we're going to look at how sampling rate has an impact on the digital representation of a sampled waveform. We do this with multiple sampling rates, different waveform frequencies, as well as different wave types. So with that, we'll get right into the lab. For our code, we set a baud rate of 115,200 to accurately read the input from the end scope to the Arduino. In our void loop, we start by making the potentiometer input and the end slope input to an integer and a float value. We then make the potentiometer input equal to the sample frequency and create a delay time related to that potentiometer input. We then set up a string of data from the end scope to send to the VSA processing code, which is then printed on the serial monitor for debugging, and then a delay is set based on the sample frequencies. For exercise 1, we wanted to see how different sinusoidal signal frequencies interacted with varying sample frequencies in a time domain and frequency domain plot. So here we have 16 different plots with a signal frequency at 75, 100, 215, and 300 Hz, and 4 sampling frequencies at 500, 200, 142, and 100 Hz. We are using the frequency domain graphs to determine if there is an alias frequency for the sample and what that frequency is. The sinusoidal signal as is being produced by the end scope, read by the Arduino, and illustrated by processing. And on the frequency domain spectrum plot, we see a term of 2.5 at 0 Hz and a peak somewhere else in the graph. The peak at 0 Hz shows the DC offset of 2.5, which will be the same for every example, while the other peak shows the frequency of aliasing, which is the frequency that processing is reading from the sampling frequency. Only 5 examples in this lab will display the original frequency and not alias, and those are the 500 Hz sampling at 75, 100, and 215 Hz, and the 200 Hz sampling at 75 Hz. These examples don't experience an alias because they satisfy the Nyquist criterion. The Nyquist criterion states that if the Nyquist frequency, which is half of the sample frequency, is greater than the original signal frequency, then the original signal will be accurately represented by the sample frequency. Summarizing our results from exercise 1. We see we have calculated the alias frequency theoretical and the experimental alias frequency and summarized it all here for each sampling rate and signal rate. And here we have the folding diagram calculations, which was used to find the theoretical alias frequency for all signal and sample frequencies. For exercise 2, we are looking at the square and triangle wave with a single frequency of 10 Hz and a sample frequency of 500 Hz. We notice looking at the frequency domain plot that there are more than 2 peaks, unlike the sinusoidal signals in exercise 1. This can lead us to believe that there are an infinite amount of incremental frequencies that all add together to form these triangle and square waves. This, as we've learned, is true and is represented by a Fourier series. Alright, that is it for the lab. I hope you enjoyed, and I will see you next week.